The first question says, given that g of x is 2x squared minus 10, find g of 2. So to find g of 2, we're going to substitute x equals to 2 in the equation. So g of 2 is going to be 2 times 2 square minus 10. 2 square is 4, so 2 times 4 minus 10. And that's 8 minus 10, and that's negative 2. As you can see, we replace the value of x with 2 because they want us to find the value of g of 2, and that gives us negative 2. And the next part is saying find g of negative 2. So now we will replace x with negative 2. So that's going to be 2 times negative 2 whole square minus 10. Negative 2 whole square is also 4, so 2 times 4 minus 10, that's going to be 8 minus 10, and once again, negative 2. In the next part, it says, solve g of x equals to 8, which means you put the function 2x squared minus 10 equals to 8, and then solve it to find the value of x. So we're going to take 10 to the other side, because 8 and 10 are like terms. So negative 10 becomes positive 10. So that's going to be 2x squared equals to 18. Now we divide both sides by 2 to make x squared the subject. That's going to give us x squared equals to 9. To find the value of x, I'm going to square root x squared and 9. Because to get rid of the square, we have to square root that term. So x is going to equal to plus minus 3. Because whenever we take the square root of a term, we get a positive and a negative value. So in this case, x would equal to positive 3 and negative 3. Then question 3, it says, given that f of x equals to 3x minus 5, find f of 3. Question number 3a, f of x equals to 3x minus 5. And they want us to find f of 3. Once again, put x equals to 3 in the function. So that's going to be 3 times 3 minus 5. That's 9 minus 5. And that is equal to 4. Then it says find f of negative 2. So to find f of negative 2, we will put x equals to negative 2 in the function. So that's 3 times negative 2 minus 5. 3 times negative 2 is negative 6. Negative 6 minus 5 is negative 11. So that's your answer. Then similar to question number 2, they're asking us to solve f of x equals to 1. So f of x equal to 1 would be 3x minus 5 equal to 1. Once again, we take negative 5 to the other side to make 3x the subject. So it becomes 1 plus 5. That's going to be 6. And then we divide both sides by 3 to find the value of x. And that's going to be 2. So as you can see in the previous case, we had x equals to plus minus 3. Over here, we have x equals to 2. Question 4 says, given that f of x equals to x squared minus 3, find f of 10, f of negative 1, and then solve f inverse of x equals to 8. So what we'll do is in question number 4, part A, for f of 10, we will do 10 squared minus 3, because f of x is given as x squared minus 3, so x gets replaced with 10. So that's 100 minus 3, and that equals to 97. Then part B, we have to find f of negative 1. So that's going to be negative 1 squared minus 3. Negative 1 squared is positive 1. So 1 minus 3 is negative 2. For part C, it says solve the inverse of x equals to 8. So to do that, we need to first find the inverse. So to find the inverse of x, what we will do is we'll first put the function f of x equal to y equals to f of x, then y equals to x squared minus 3, because that's what the value of f of x is. Now, right now, the subject of the equation is y. We have to make x the subject. So in order to do that, we're going to take 3 to the other side. So it's going to be y plus 3 equal to x squared. Now, since we're trying to make x the subject and right now x squared is the subject, so what we will do is we will square root both sides to get rid of the square. So that's going to be square root of y plus 3 equal to x. So last step, replace x with f inverse x and y with x. So your inverse is root of x plus 3. Now they want us to solve the inverse equal to 8. So if the inverse equals to 8, that's going to be square root of x plus 3 equal to 8. Same thing, square both sides because right now we're trying to get rid of the root on x plus 3. So it's going to be x plus 3 equals to 64. And x equals to 64 minus 3, which gives us x equals to 61. That's your answer. The next question, it says that given that f of x equals to 2x minus 4 and g of x is 3x plus 5, find g of f of 3. Now this is a composite function. First, I'm going to find the value of f of 3. So f of 3 is going to be 2 times 3 minus 4, which is 6 minus 4, and that's 2. So now we're going to substitute this value of f of 3 in g of x because they were asking to find g of f of 3, which is now basically g of 2. Why? Because f of 3 has the value of 2. So g of 2 is basically going to equal 3 times 2 plus 5, which is 6 plus 5, and that's equal to 11. An alternative method that you could have used was that if we had instead found g of fx first. So g of fx would have been found by replacing the x in gx with the function f. So that would be 3 times 2x minus 4 plus 5. As you can see, we replaced the x in g of x with f of x. So now expand the brackets, that's going to be 6x minus 12 plus 5. So that's going to be 6x minus 7 because negative 12 plus 5 is negative 7. Now to find g of f of 3, that's going to be 6 times 3 minus 7. 6 times 3 is 18. 18 minus 7 is going to be 11, which you can see is the same as what we did in the first method. So both methods are correct. You're going to get the same answer, but you can pick the one that best suits you and takes less time to solve. Then to do part B, that says work out an expression for the inverse of x. So to find the inverse of f of x, we need to first put y equals to f of x, which is going to be y equals to 2x minus 4. Right now, the subject of the equation is y, so we need to make x the subject. In order to do that, I will take 4 to the other side, which makes it y plus 4 equals to 2x. Now I will divide y plus 4 by 2, because once again, we're trying to make x the subject. So now we have x equals to y plus 4 over 2. So the last step is going to be replace x with f inverse x and y with x. So that's going to be x plus 4 over 2. As you can see, f of x was 2x minus 4, and the inverse is x plus 4 over 2. Both are completely opposite of each other. In the original, we were subtracting 4. In the inverse, we're adding 4. In the original, you're multiplying x by 2. And in the inverse, we're dividing x by 2. Now for part C, it says solve f of x equals to g of x. So we know f of x is 2x minus 4 and g of x is 3x plus 5. So We put them equal to each other because that's what they're asking us to do. So that's going to be 2x minus 4 equals to 3x plus 5. Now to solve this equation, we're going to collect like terms on each side. So I'm going to bring the x on one side and the constants on the other. So I'm going to bring 5 to the left-hand side, which makes it negative 4 minus 5. And 2x to the left-hand side, so that's going to be 3x minus 2x. So this goes over here, and this goes over here. So negative 4 minus 5 is negative 9, and 3x minus 2x is x. So your answer over here is x equals to negative 9. This is called this over here, and this over here. In question 6, it says, given that f of x equals to 3x plus 1 and g of x is x squared, find f of gx. So once again, we're going to find a composite function. So since we're asking us to find f of gx, that means that gx is the new domain of f of x. In the original equation, we have x as the domain of f of x. But now they've asked us to put g of x as the domain. So we're going to do f of gx, which is going to equal to 3 times g of x plus 1. So replace g of x with its value, which is x squared. So that's going to be 3x squared plus 1. That is f of gx. Then it says work out an expression for g of fx. Now it's the opposite thing. So now the difference in both the equations is that in the previous case, g of x was your domain, but now f of x is going to be your domain of g of x. So that's going to be x squared. So x squared gets replaced with f of x whole square, which is going to be 3x plus 1 whole square. Now you can expand the bracket, which would be 9x squared plus 6x plus 1. Then it says solve f of gx equals to g of fx. So that means we're going to put our answer to a and b equal to each other, which is going to be 3x squared plus 1 equal to 9x squared plus 6x plus 1. So collect the like terms on each side. 3x squared minus 9x squared and 6x plus 1 minus 1. That's going to be negative 6x squared over here and 6x over here. Bring the negative 6x squared to the right-hand side. So that's 6x squared plus 6. Since we have 6x common between both the terms, let's take that common and we'll have x plus 1 in the bracket. So one value is 6x equals to 0 and the other is x plus 1 equal to 0. So x is equal to 0 and x is equal to negative 1. That is your answer. In question 7, it says, give that f of x equals to x squared minus 17 and g of x is x plus 3. Work out an expression for g inverse, f inverse, and then solve by putting each of them equal to each other. So for the first one, g of x is given as x plus 3. Put y equals to g of x. That means y equals to x plus 3. Then we make x the subject of the equation. So y minus 3 equals to x. So g inverse x would be x minus 3. Now for part B, we find the inverse of f. So f of x is given as x squared minus 17. So y equals to f of x, that's the first step, which means y equals to x squared minus 17. Bring 17 to the other side, y plus 17 equals to x squared. And to make sure x is the subject, we will take square root on both sides. So now we have square root of y plus 17 equals to x. Hence, f inverse x would equal to square root of x plus 17. In the last step, just replace the y with x and the x, which is the subject, x, which is the subject with the inverse function. Now for part C, they want us to solve both the functions equal to each other for the inverse. So it's going to be f inverse x equals to g inverse x, which is square root of x plus 17 equal to x minus 3. So to get rid of the square root, we will square both sides. So that will give us x plus 17 equal to x minus 3 whole square. Let's expand the bracket on the right-hand side. So that's going to be x minus 3 times x minus 3. We multiply x with x minus 3 and then negative 3 with x minus 3, which is basically going to give us x squared minus 3x minus 3x plus 9, which equals to x plus 17 equals to x squared minus 6x plus 9. Now collect all of the terms on one side. So that's going to be x squared minus 6x minus x plus 9 minus 17 is going to equal to x squared minus 7x minus 8. So now we factorize this quadratic equation. So that's going to be x squared minus 8x plus x minus 8, which is going to be x bracket x minus 8, because we factor by grouping, and in factor by grouping, we split the equation into two groups. So in the second group, we have plus 1 common. So that's going to be plus 1 times x minus 8. So we take x minus 8 common from x plus 1. So x plus 1 comes in the second bracket. So one value of x is going to be 8 and one value of x is going to be negative 1. And that is going to be your answer. In question 8, it says that the function is defined such that f of x equals to x squared minus 1. Find an expression of f of x minus 2. So originally, the function f of x has a domain of x, which gives us the expression x squared minus 1. So to find the function for f of x minus 2, we're going to replace x with x minus 2. So that's going to be x minus 2 whole square minus 1. You can expand the bracket, which is going to be x minus 2 times x minus 2, which will give us x times x minus 2 bracket x minus 2, which is going to be x squared minus 2x plus 4 minus 1, and that's x squared minus 4x plus 3. That is the fully expanded function for f of x minus 2. In part B, it says, hence solve f of x minus 2 equals to 0. So since we already expanded it, we can put this function equal to 0 and solve this quadratic equation. So first, we would multiply the coefficient of x squared with a constant, which gives us the value of 3. Now we find factors of 3. Factors of 3 are just 3 times 1. So since we've only just one set of factors, so we will use the set of factors to replace the middle term, which is -4. So we'll write the equation as x squared minus 3x minus x plus 3 equal to 0. As you can see, the -4x gets replaced by minus 3x minus x. Both are the same thing, but written differently. So now to factorize this equation, we're going to split it into two groups. First group is going to be x squared minus 3x. And the second group is going to be -x plus 3. So if you look at the first group, we have x common. So that's going to be x times x minus 3. And the second group, we have -1 common. So that's again going to be x minus 3. So between x and -1, we have x minus 3 common. So that's going to give us x minus 1 in the second bracket, where x equals to 3 and x equals to 1. These are your values of x. Then in question number 9, it says that the function f is defined by f of x equals to 4x minus 1. And the first part, they're asking us to find the inverse. So let's first put y equals to f of x. So y equals to 4x minus 1. Let's make x the subject of the equation. So it's going to be y plus 1 equals to 4x first. And then y plus 1 divided by 4. So as you can see, x is the subject. Now in the last step, replace x with the inverse. So f inverse x and y with x. So x plus 1 over 4 is your inverse. Then it says g is defined as g of x equals to x, g of x equals to kx squared, where k is a constant. Given that f of g2 is equal to 12, work out the value of k. So g of x is kx squared. And f of g2 is equal to 12. So if we find g2, that's going to be k times 2 squared, because x gets replaced by 2, which is going to give us 4k. Now, if we try to find f of g2, that means we're replacing the domain of function f with the value of g of 2, which is 4k. That is going to be 4 times 4k minus 1, which is 16k minus 1. Now, since f of g2 is given as 12, so we put this equal to 12, which is going to be 12 plus 1 equal to 16k. That is 13 equals to 16k. K is going to be 13 divided by 16. And that is your answer. If anyone is still struggling with understanding the basics of composite and inverse function, I'm going to attach the link at the end of the video, and you can just go through that and develop more understanding for this topic.